Good morning, everyone, including those who are still on the coffee break. We are starting. So welcome to everyone. I hope that you liked yesterday. It was very tiresome, but very interesting for me as well. And I hope that you managed to get the best of each panel. We went through the resource availability in the different countries in the Southeastern Europe for Bulgaria, Romania, Greece, and Turkey. Then we switched to how to make a project for renewables achieve better return on investment, what we do for different quality checks, and how do we develop the project from the very start that incorporates sustainability in its core, let's say, and different different criteria that make a project successful. We talked about the financing. We did a little bit of examples of how corporate companies around the sector decarbonize themselves in the different stories. And today we have the biggest success of all, because there are a lot of resources, a lot of investment interest, and everything looks fine for a renewables revolution to happen, but in reality, we do have a lot of challenges and a lot of roadblocks on the way to overcome before we can really transition to an electricity-based system that counts on variable renewable energy, which is solar and wind particularly, because they managed to win the battle for the lowest cost of electricity. So today we're gathered here with a pretty diverse panel, and we want to present to you really how do we make this transition. Do we count on the transmission? How do we distribute to the final clients? And how do we include storage, both well-known technologies such as hydro pumped storage in Bulgaria, for example, and more like new application of the batteries for grid scale and industrial storage of electricity. So once again, welcome again to the second day of the Resource Southeast. I'm Mariyana, I'm your moderator today, and we will lose no further time. Starting with our first guest here, I would like every participant on the panel to just say a few words about themselves and their background. And I will ask a very specific question for a start to each of them. After that, we will continue with the discussion. So, Mr. Zarchev, I'm really happy that you're here with us today. And to you, I have a very specific question. So, why transitioning to an electricity system largely based on variable sources will require greater regional integration? And what does it mean for our system to transition to that? What are the challenges and what are the transmission system operators within the region looking at as a solution to that?
Thank you very much for this introduction. Hello to everybody. My name is Dimitar Zarchev. I am currently director of the National Dispatching Center, VSO. And also I'm a board member of ENSTO-E, the Association of the Transmission System Operators in Europe for Electricity. So it's interesting. Somebody said that you should be lucky when you are living in interesting times, and these are the most fascinating times I have seen. Because we were thinking that this is a conventional system, nothing will happen, will continue in the same way, but now everything is changing. As you know, because of Fit for 55 and this goal for the Green Deal, we have to use more and more renewable energy. But this renewable energy is now built everywhere around Europe, which brings us to a very interesting situation, because actually the grids of the transmission system operators, the whole transmission system, was built many years ago around the conventional power sources, servicing the load in the big cities, big industrial consumers, and so on. Now, all the places where the renewables are installed, they have this infrastructure that is not sufficient to be able to transport the energy that is generated by them. And there are various other issues and questions that needs to be answered in the future before we really go to this green transition. So if I have to summarize at the moment this situation, I would say that as TSOs, not only in the region but all over Europe, we are suffering from several quite interesting situations. First of all, this is the low density of the transmission grid infrastructure. Because as I told you, the renewables, they are coming to places where we don't have sufficient grid. And it's not valid only for Bulgaria, but it's valid all over Europe. Also, because of these new sources, which are not planned originally in the transmission grid and which are creating, let's say, random flows through it, we are continue to suffering and to see the increased amount of low flows, which are really jeopardizing the security of the system. Also, we are seeing how the massive RES increase is now on its way to come to the networks. I can tell you that even only for Bulgaria, we have at the moment connection requests for something like 38,000 megawatts of RES to be connected to the grid. Probably some parts of it will not be used, but there will be a significant increase of the renewables. I can tell you that only for 1 year, only in Bulgarian grid, we have increase of renewables by 1,000 megawatts. So you can imagine the velocity and how it is becoming bigger and bigger, this effect. The other effects that we are suffering from are, of course, the effects of recently synchronized grid of Ukraine and Moldova. You know that the situation there is quite rough, let's say. And this is emerging in additional operational challenges that we are all facing. As you can imagine, we are electrically quite close to their grid, and after the bomb attacks, system splits there, and so on, there are a lot of energy that is going in both directions, and actually is creating also low flows there. And when we get all these effects together, already today, we as operators, we are facing really operational challenges. Challenges how to maintain the balance between consumption and generation, how to maintain the schedules for export and import, and how to maintain even the stability and the voltages in the grid. And this is the main question: what about system stability? What will happen in the next years when we have mainly renewable network with some conventional sources placed in different parts of the grid, creating inertia, creating transient stability, creating steady-state stability. This is maybe the most, how to say, nice picture to show you what is happening. This is actually an event that took place in 2021 on 8th of January. Due to low loads after the holiday season, and due to a lot of generation that was coming from the south and from the east towards north and west, we had a situation where we were almost overloading the lines. They were working almost at their stability limits. Actually, the thermal limits of the lines were already crossed, and they were going to their disconnection limits. You can see here the dark and the light. This is actually a representation of the electrical angles between the two parts of the system. So if you imagine that this is a car and we have to drive it, the suspension and the gearbox is somewhere in the middle, the engine is on the left, and everything else is, the suspension is on the right, as you see it, and everything else is on the left. And there was no connection, you know, the engine was making much bigger effort than it could be bared by the rest of Europe. This led to disconnection of both parts of Europe, so we stayed disconnected and our frequencies were different. If you want to see the details about this event, you can, of course, go to the site of ENSTO-E. There is a link, and you can read in details what happened. What I want to show you with this picture is that, first of all, there is a stability problem, as much as the renewable generation is penetrating in our systems. And also, there is a grid problem, because no operational measure and redispatching cannot replace actually the grid and the sufficient highway on which the electricity to be transported. Of course, all the TSOs are working on this issue and these matters. And on the next slide, I'm just showing you an extract of the 10-year net development plan of ENSTO-E, which covers all parts of Europe, of course, because it's a plan for all the TSOs. And as you can see, even with the most, how to put it, taking into account only the national plans for energy and climate, which are quite, let's say, conservative on this matter, you can see that there is a huge need of interconnection and there is a huge need of storage. More yellow it comes, more storage you need. What do I mean by this? Actually, when you have a generation that is volatile by its nature because of the source, and you need to maintain the balance 24/7, you need either to transfer huge amount of energy all over Europe and be able to dispatch it, which says grid and which says evolution of markets. Either you need storages in order to be able to store it and to use it when there is a need of it. And when I'm saying storage and I'm saying renewable penetrations, I'm not even talking about storages on daily basis. I'm talking about storages on weekly basis and even on monthly basis. Maybe somewhere in the distant future, this is something I don't know, these storages will have to be seasonal in order all this energy to be stored and to be used when actually the load is coming. That needs to be covered by this renewable energy. So in summary, what I want to say, this was the last one. So in summary, what I want to emphasize here is that actually, as TSOs, and of course we are already working on this, we need three things. We need flexibility sources by means of storages, flexible generation, and systems that can provide the system services, but not only frequency system services. Also, I'm emphasizing, and this is extremely viable, and it will become very valuable in the future, the non-frequency services, because when you have renewables in your system, you don't have some of the basic services that are provided now by conventional generation, by means of voltages, reactive power, fault ride-through capabilities, and so on and so on. So what we do at the moment, in very close cooperation on regional level and between the regions, of course, we had already this type of events. It was last month because of excess of renewable generation through low load conditions. We are maintaining the balance with conventional measures by means of redispatching. But we are driving the interconnected network already to its limit. The plan, yes, is already there. You can see just an extract from it. It will evolve, of course, in the future, because in 2 years there will be a plan that will be more ambitious than this one. And nothing from these measures that we are taking today will replace two things: flexibility and grit. And we really need, if we want this Green Deal to be pushed up, we really need to evolve this grid and to redesign it to reply to the needs of the consumers and the needs of the generation. Because otherwise, we will not, will stop, let's say, we'll stop at one point. And this is my honest opinion. If we don't do this in the coming year, in the next 10, 15 years, the Green Deal will stop at one level and it will not satisfy the needs that are already placed in this Green Deal document and Fit for 55 document. So this is my message. Thank you, Mariyana.
Thank you. I think you were quite clear. Grids and flexibility, and not only in terms of storage, but also in terms of ancillary services. That's the TCO view. And now lowering a little bit on the voltage level and turning to Anna. Maybe you can tell us what are the most pressing issue on the DCO side?
Well, they really don't differ that much from what has been just mentioned on a TSO level. Of course, the scale is a little bit different, but again, we have to be a highway, not just in the direction of the client, as you mentioned. We don't distribute anymore just to the client. We have to be able to take their energy, their e-vehicle load one day as a system service either at the level of the DSO, or if we have sufficient TSO-DSO cooperation and communication systems, also is the challenge that the TSO is facing in the particular moment. I would like to focus on the topic of grid reinforcement, because for us, really, this is the moment when we realize that the grid indeed needs to be sufficiently redesigned, but physically redeveloped, and a lot of hardware to be added to it. Hardware that is smart enough also to communicate. So software too is part of it, which makes the challenge from a logistical point of view a real let's say, favorite task for our colleagues in the DSO company, because in this environment of low access to labor force, not sufficient ability to get deliveries on time on physical infrastructure that they need, or the necessary software to be really properly defined in the beginning, is really making today's challenge really unattainable in the fast deadlines that we needed, basically tomorrow. And as you know, the distribution system operators, from the moment the resilience and recovery plan was announced as an opportunity and a vehicle to receive funding towards grid reinforcement, have been trying to get access to this funding. And the reasons have been actually twofold. Indeed, we are capable to plan sufficiently our own investment programs, and perhaps in light of the developments that we see, we would be confident enough to invest also in the direction of really doubling or sufficiently increasing our investment programs. However, it would come at associated costs that we need to decide whether we are able to afford at this stage, and the society as well. Therefore, we really try to emphasize that it is necessary to receive this funding as grant. It would really help us to frog leap the developments of our natural investment program and really supplement it. However, let's say now that we have been able to secure such financing, which is nearly 30% extra on our usual investment program for the next 2 years through the modernization fund and the funds allocated particularly for Bulgaria, I must say that the colleagues who will have to implement this project are really anxious how they'll manage to do it at the velocity that the environment and the grid needs it. Therefore, looking at the investments, the incentives, pardon me, that we need really to maintain the stability of the grid and provide it to be the secondary and primary roads of the electricity system, we also perhaps need really urgently to have local flexibility markets developed so that we can have access to this services prior to us being able to have the grid reinforced to the stage that we hope in at the hardware level. And we are really looking forward to the results of the electricity market design efforts at EU level that hopefully will be finished by this year as a real vector for this change also on a national level, allowing DSOs to be able to partner both with the TSO in this challenge, but also with some of the companies and the service providers that we will be hearing more from in this panel. And we will have another question about regulatory challenges, so I'll stop at this now to be able to offer the stage to the other participants.
Thank you, Anna. It was so great to see the perspective on the decentralization of the grid management in a way. And turning to Martin, we know that Bulgaria has a relative advantage on being able to integrate a higher share of renewables thanks to the hydro capacity that we have already built, and thanks to a little bit the advanced hydro pump storage. But we know that the National Electricity Company faces some challenges on that respect, both from climate change. We now see the examples of Portugal and Spain, where droughts are severely affecting hydro generation capabilities. And we know that we have some technical trouble with our hydro pump storage. So I would really appreciate your honest answer on how NEC is planning on strategic basis to tackle those challenges.
First of all, I would like to thank you for the chance to take part in this panel and overall in the event, which I find excellent, and I'm very happy to see so many participants from worldwide, I would say, not only from the region. This clearly expresses the interest and trend in the decarbonization and development of renewables, and of course all specifics, let's say, which accompany this development. Some of them, the grid aspects were already mentioned. As general comment, I think what we experience is that the penetration of renewables is running at a very fast pace compared to the slowly moving normally energy systems, in the inertia in the energy system. So the development overall of grids and storage cannot run at such fast pace. NEC is operator of the first being the largest producer of energy from renewable energy sources in Bulgaria, and second being the first largest storage operator in Bulgaria. We understand very well our role in the decarbonization, and we are doing our best efforts, of course, to support this process. NEC is is capable to store around 2 terawatt-hours of electricity on annual basis, which can be stored both on daily basis and seasonally, even over the years. So yes, I might say that being in this role, I'm very happy, and we are really doing our best efforts to support these assets to run efficiently and to support all your investment plans, and also to support the TSO as much as we can. Unfortunately, what we experience is that in the past, somehow these assets were taken as granted, something which just exists, which does not need to be maintained, does not need to be invested in it. For many years, the investments and the rehabilitations have been severely delayed, more than twice, let's say, 2 times longer periods between rehabilitations compared to recommendations of producers. All this, of course, at the end results to a low availability and technical issues which were mentioned, and I believe most already know in some of these ones. What we experience also, unfortunately, is that overall worldwide, during the last probably 20 years, the focus on hydro has been significantly reduced due to the market situation, and lots of the expertise has been lost, or new expertise has not been developed we really face difficulties to find engineering companies which have free capacity to focus on new projects or to focus on priority projects. Usually their time is spent 1-2 years ahead, they are fully booked. So this is something what we experience. At the same time, at the moment, there is a big boom worldwide also on construction of dams, hydropower plants, pump storages. But this is logical result of the market situation. What is crucial also for storage in Bulgaria, for development of storage, is the fact that the regulation is not supporting actually the investments in new storages or even in existing ones, is not financially supporting. The cost of or the price for providing system services and balancing energy, unfortunately, does not support investments so far. So crucial is that this regulation is changed in order both existing assets or new investments, including in battery storages, to be implemented and to be bankable effectively. So this is my message. It is mainly in the comment towards the parliament and also in the capacity of the regulator, that the pricing of these services should be adapted in a way to really support operation, because we face some cases where we are providing balancing energy, for example, to the TSO below our purchase costs. This is in the cases when the day-ahead market is at low levels, which is, everyone understands that this does not make any sense, and this does not support any development of new storage.
Thank you, Martina. I think that you touched upon a really important topic of how the market rules affect the business models of the flexibility that we so much need on the grid. And this is certainly a message that our panel will try to send. But on the other hand, there are also a digital challenge when integrating the different flexibility solutions. And I will here turn to Peter, who has something to show us of a solution probably on the side. How do we integrate the different flexibility solutions, and how do we make this work in practice?
Yes, thank you, Mariyana. Nice to be here. Happy to be able to share our experience with you all. When we actually started this company in 2010, we had a strong belief that all energy should be renewable and flexible. However, we have seen yesterday that the pipeline for renewables is huge. There is a lot to be built, but we already heard today that we can't just build renewables. We also have to do something else on the tools, on the mechanisms to actually support this integration of renewables into the grid, so that the grid can still function as it used to be, to provide security and reliability. So we have to provide additional flexibilities for the grid, so the conventionals are not going to be sufficient anymore. Conventional, I mean more like hydropower plants, thermal power plants that are today providing flexibility to balance the system. So we have to try to unlock all the flexibilities that are out there, meaning flexibilities from industrial customers, meaning flexibilities from small generation power plants like small hydro or even CHPs, and lately, of course, also from the batteries. And make these flexibilities useful for different power system use cases, like balancing transmission power grid, or even on a DSO level. We have heard that there is a need to establish local flexibility markets to address voltage issues or congestion issues. So these are all use cases that help integrate more renewables to the grid, But of course, we need tools to do that. On the last panel yesterday, we already heard that there are tools out there. They exist, even for carbon-free production of steel, which was quite amazing, surprising to me. Regarding the flexibility management, you can see here on this slide a tool that Cybergrid developed over the last 12 years. We have been able to support with this tool many different suppliers of electricity that actually evolved also in flexibility aggregators over time. Aggregating demand response assets like industrial customers, commercial customers, factories with pulp and paper production, steel production, or aluminum production, or even some not pharmaceutical, but the chemical producers. Then different CHPs, even diesel gensets as a backup units, hydropower plants, small hydropower plants, and with EVN, which bought Cybergrid last year. So we are 100% owned by EVN Group since March last year. We are now even connecting their pump hydro storage. So we will operate quite large pool of flexibilities in Austria, comprising hydropower plants, pump hydro storage, industrial customers, CHPs up to 80 megawatts. And this will be provided as secondary and tertiary control, AFRR and MFRR, to the APG, Austrian TSO. And we'll fully support already Picasso and Mari platforms. So with this kind of a tool, aggregators, electricity suppliers, or even storage operators or large industrial groups can actually pull together all these different types of flexibilities and monetize them on different markets. At the moment, the balancing markets are the most financially viable. However, in the future, we believe that the DSO flexibility markets will be also an important part of the electricity landscape. And yesterday we heard also an idea or suggestion that PPAs and demand response should also be coupled and support each other in order to additionally boost the investments into the renewables. So we have a tool that's capable of doing all that, and it has been, in use since, in practical use on the market since 2013-14, providing flexibility to different TSOs. Thank you.
Thank you, Peter, too. I think it's amazing to see what you can do with the data once you have it gathered. And passing the word to Rosa. Last year, we had another representative of Fluence here with us, and we were talking about the future application of the battery storage as a transmission asset. And I'm very happy to have this continuity and this panel where you can show us the result of what we talked last year and how fast actually battery energy storage can be implemented to help with the grid flexibility. So Rosa.
Yeah, thank you and good morning, everyone. It's a pleasure to be here. And today I'm gonna briefly touch some application of storage in support of the transmission grid. Before we go into the topic, for the one who don't know Fluence, I just want to introduce the company. Fluence is a global leader in battery energy storage product and solution. So far, we have implemented globally more than 6.6 gigawatt hour hour of energy storage project in more than 47 power markets around the globe. And our team has gained extensive experience in regulatory processes. We also own a digital platform, Mosaic, that is an automatic bidding software, and Nispera, that is a renewable asset management. So going into this conversation, if we see how the electricity grid is organized, so from one side we have the power producer, the conventional generation, but also the renewable that are coming online, and from the other side the consumers. In between there is all that network of wires, pole, the transmission line, and the distribution network that has the great ability of bringing the electricity from the producer to the consumer. If we add battery energy storage into this equation, battery energy storage has been largely involved into generation, so mainly in conjunction with the renewable, dispatchability, avoiding intermittency, and a lot of ancillary services, and as well as the consumer with all that pool of residential, commercial, and industrial. So far, globally, more than 35 gigawatt hour of battery energy storage project has been deployed in this segment, and the number will continue to grow. In the area of the transmission grid, which is actually a huge sector, battery energy storage has not done a big impact until now. But by the way, SP Global has estimated that till 2030, more than 50 gigawatt hour of energy storage will be needed in support of the grid. If I have to summarize and squeeze what are the value and the benefit of battery energy storage into the transmission network, I have narrowed down actually to two, which almost also touched with the other panelists. The first way is transporting the electricity cost effectively. And here we have to consider that as more renewable will come online into the grid and project will be deployed, the plant will be located where the resources are available. There might be remote area, distance location, where the transmission grid built maybe years ago was not designed to manage that increased load. This can cause curtailment, redispatch, with severe consequences on the reliability and stability of the grid, and also economical consequences for the society in case for any blackout. Battery energy storage can avoid curtailment and the redispatch cost, storing that energy without stopping the production and releasing at a later moment, and also will allow enhancing the utilization of the transmission line. So being a critical infrastructure that is not allowed to fail and must maintain reliability, there are lines that are kept as backup, okay? So that does mean that the full infrastructure is not fully utilized. The battery energy storage can actually work as a backup, where in terms of milliseconds can be activated immediately to bring the system back online and give the system operator enough time to bring the infrastructure back to a stable condition. Now, this is a very summarized concept, but actually is a reality, because this is behind the concept of the project in Germany built with that Fluence is building for Transnet PW, that is a 250 megawatt, also called the grid booster. But also Australia is implementing a project exactly in these two regards. The second value, and this was also touched briefly by and extensively by the panelists before, is securing reliable system operation. And again, here notoriously big rotating machine, synchronous generation is needed as the renewable increase, to maintain that critical grid stability services, that system strength coming from inertia and voltage. In this regard, we have also to consider that this technology will start to decline and be retired. Meanwhile, the inverter-based generation coming from renewable is increasing. So the industry, the battery energy storage industry, mainly a few years ago, started to investigate can the battery energy storage that is an inverter-based technology actually be implemented in support of critical grid application? And I'm talking about synthetic inertia, virtual synchronous machine, as well as all the functionality that come with a grid forming and grid following inverter. This is also a reality. So these are no longer a pilot project, but real industrial project. And for example, with regards to Fluence, we have been implementing in Lithuania for a 50 megawatt battery energy storage project that are located next to substation, which in addition of providing this storage application for system stability, it's also act as an important energy reserve for the Baltic grid, allowing them to disconnect from the Russia interconnector and connecting via Poland. But also Australia has been implementing the battery storage for stability service, and also the program of Stability Pathfinder in UK is also a great example of energy storage being deployed exactly for system strength. And just to wrap it up and close up, because everybody thinks to battery energy storage to just batteries, but actually a battery energy storage system that is deployed with renewable is totally different from a battery storage system deployed in a transmission line, okay, as a transmission assets. And this come because we are supporting an infrastructure that cannot fail. So the level of liabilities and the technicalities are higher, 99% availability, for example, higher redundancy, cybersecurity, as well as advanced and enhanced control and inverter features become extremely critical. As Fluence is really targeting this segment and starting to support several countries around Europe and also in other continents, and we have decided to develop a specific product called UltraStack that embed all these functionalities. And so far we have been building more than 500 megawatt exactly into this segment. And that's my short summary about this, and happy to continue the conversation with your question later.
Thank you, Rosa. I think that you made a great point of how battery energy storage is not just the battery, and the whole system depends a lot on the application that it will have. So I will turn now to Theodore to tell us a little bit more of how we can step up the storage and the pull capability of a smaller systems generator and demand response. Perhaps he has been part of a very interesting project on FlexiGrid and how this turns like a virtual power plant or close to it. So please tell us more about this.
Thank you. Dobro utro and good morning to everybody. Thank you for having me here. It's a pleasure to see the energy in this forum. It's the energy of the people that drives the transformation of the energy sector. We spoke about energy transformation a lot yesterday, today. It comes with a challenge. The trend is obvious, we'll become greener. And it's true that the energy system of tomorrow will be different. It will be in 2050, we'll have much more renewables, we'll have much more prosumers, we'll have much more active consumers. And unfortunately, we have less and less big assets that the TSO may use for flexibility services, which of course open the place for creating a new market of flexibility where we use the power of many, the power of the small consumers, of the new prosumers, and the distributed energy generation to procure these flexibility services at DSO level to help the grid stability. Why and how is this possible? I mean, when we speak about the biggest challenges, like what we have to invest in the grid, what we have to invest in the battery, it's always linked to big investments. It's always linked to long development time. It takes time to do this. This is the base. This is what we need to support the energy transformation. In the world today, the digitalization and the development of digital technologies is happening outside of the energy. We in the energy sector have to benefit from all these technologies. And today we're not benefiting enough, we're not deploying them enough, but technologies like blockchain, technologies like artificial intelligence, IoT, this is a relatively easy and cheap way to help the energy transformation. So with the help of the IoT, what we are doing is we're actually creating a platform where we are allowing the small consumers and prosumers that are connected to the DSO network start having a different role, being able to provide flexibility services. There are many numbers, but small in size, and it's also a challenge what kind of commercial platform to create that allows a cost-efficient way to communicate and to trade with that. Yeah, it's obviously that the DSO will never be able to issue 1,000 invoices for 10 stotinki or 10 euro cents per invoice because somebody have provided 1 kilowatt hour or 10 kilowatt hours supporting certain period of time. Although all these small in together, they will have an important role. You know, they may come to 10 or 20 megawatts. That's important in this particular moment for either energy management or sometimes also for grid management. So the blockchain technology, which is already developed and in the market, allows actually for such cheap way to transact, to record the transaction, even to make the payment. And this is an example of how these digital technologies developed for some other sectors can actually be used today to create some benefit, to help also in this process of transformation. Again, the grid upgrade is needed, the battery storage is needed, the big hydropower plants and big storage and the hydropower plants is much needed for this transformation. We cannot add 4,000 megawatts in Bulgaria if we don't have that. But can we deploy the digital technologies today in a way that allow to add 500 megawatts maybe without big investments and without big delay? I think the answer is yes. So yeah, again, this trend is already observed. The TSO is also doing a lot, and I know the DSO is also doing a lot in this process. I know the regulation is maybe not yet here, but it will come. It will come because the need is here. And in many countries, like you heard also earlier from this cyber grid project, in many countries it's already a fact. It's already happening. It's already helping energy transformation. So yeah, my message is that in the digitalization of energy sector, there is a value that we can easily, there's a long-hanging fruit. There's some benefits that we can easily get if we do it, and it's relatively cheap.
Thank you for that message. I think that it's very important because sometimes we don't see the opportunities that are right in front of us and are easy to access. I hope that you managed to get a good overview of what is possible on the different TCO, DCO level, how we can even on our small scale still be participant in the market. But I have a very big question for our last participant to speak. Faisal, you have the hardest of all questions about the cost and how do we actually do the business model?
Yeah. So thank you for inviting me to the panel. So I'll give you a short introduction. I work as a storage expert as a DNV. We're heavily involved in the energy transition, trying to support different companies in these. And this is an interesting region, but even what's happening around Europe as well. We have the luxury to be involved in quite a lot of projects, a couple of hundreds of them a year for sure. So we have some data on what's going on in the market. I'll try to cover a little bit on what's happening on the best side in terms of capex and opex. Everyone, we heard a lot from the DSO, TSOs about different services. We heard from Fluence on the products and different projects, but the main thing before you even start it actually to get the business model up and running. So in terms of, I start a little bit with capex. In terms of capex, there's a big investment for storage, a huge investment. And what we've seen last year is quite incredible with the increase of capex prices. First time since we've been in the market for the lithium battery storage, we've seen that increase. It's quite incredible. I think we calculated and we did the study to 8% of increase in capex. And what's going on? Obviously, there's a lot of backgrounds and issues. First, there's political tension. There's raw materials. There's a lot of going on behind this increase. What's going on in the future? That might be the most interesting. What we've seen that it probably slightly going to be it's been a slight increase in the beginning of 2023, but it's probably going to stabilize and start going on to normal level. Important regarding capex is actually look at we heard a lot about different services, so look at the business model and look at the scaling factor. What do you actually want to do? You bigger you scale your system, you lower you're going to have your capex. So if you go for a everyone talk about the 1 hour system for flexibility services, or you go for a system with 2 hours or 3 hours, that means you're going to decrease your capex. And you're going to have a lower capex on US dollar on kilowatt hours. So look at your business model, look at the scaling factor, look at how big system you want to have, and also look at the future, how long you're going to have this system, for how many years. And then you get reasonable what kind of services you want to provide, and what is actually important for in terms of a bigger system. Obviously, as advanced in terms of engineering cost, in general project cost as well, it's also going to be an advantage. It's also in terms of sourcing the so the big cost of the, if you look at the capex of a BESS, last year it was 65% of the capex was the battery pack itself. So if you go for a bigger system, that means that you have a more likely chance of sourcing your battery pack and getting a better price on that. So that's a trend that a lot of investors, developers try to option for bigger system for future proofing, and also be able to source the battery pack, because it's a bigger restraint and constraint in the battery pack or the batteries at the moment, not only because of BESS, only because of transition of the EV cars also demanding a lot of batteries as well. So there's a constraint here to be able to secure those battery packs. That's the tips regarding capex. The rest of the capex, 65% was in terms of the battery pack. You have the balance of the system, right? The big inverters and everything around that. That's going to cover around 20 to 25% of the. And I'm not going to go into detail. I'm running out of time, but that a big tips regarding the trends of the capex. I think eventually over time, we're going to go back to more normal and see a decrease again. There's a lot of battery factories coming up around this region, and the market is stabilizing. So over a year, I think we're going to go back to seeing a more normal market, to say. Regarding the, let's touch upon a few minutes on the OPEX as well. Regarding the OPEX, I would say that it is easier with the BESS. You don't have any movable parts. You don't have any variables. It's not a wind turbine that you need quite a lot of maintenance and stuff. So it is easier in terms of OPEX. We see that we didn't see a incredible increase last year. Instead, it's stabilized and it's decreasing over time. You're getting better OEM agreements with the developers, and you have, of course, in the OPEX, you have a lot of local cost, and we already mentioned like land lease and these kind of things with needs a lot of growth. So it's hard to predict, and it's hard to give a fully trend on, because it's, some of the factors in the OPEX is very much dependent on the region you are based in. But in terms of OEM agreements, we see a lot of decreasing, a stable decrease. I think that's it from my side. I hope I could give some insight on the CapEx and OpEx.
Yeah, that was a very brief and interesting overview. Thank you for that. And before I open the floor to questions from the audience, I hope that you have thought of them already, and someone will soon be prepared with the microphone over there. But last question from me to all the panelists. We talked about the challenges and the tools for incentivizing more flexibility to the grid and coping with this higher share of renewables that we will have, just in terms of the pricing base of it. But in your own opinion, what needs to change in the regulatory framework and the market rules? And are there any, let's say, already suggestions on the table that we can look at with in the near future? Starting again with Mr. Zarchev, perhaps, and going clockwise.
Okay, yes, of course. A lot of suggestions on the table. Actually, a whole new market design all over Europe that is not only touching these problems, but it's going deep insight what is already mentioned here by all the panelists. And if you look carefully through the document, you'll see that all the topics that were touched here, they're actually very well explained in this regulation. Also a TSO-DSO regulation that is expected to come maybe now, not next year, but the year after, because now it's under preparation between the TSOs and DSOs in Europe, which is also unlocking this type of flexibility that can be provided from active DSOs, because at the moment DSOs are still behaving like they have passive load and they just need to be supplied and to transfer this electricity towards the customers. But on the contrary, on the other hand, they're quite an active consumers, because what we see actually even at the moment, in some conditions, they're really generating electricity towards the transmission grid. So this is, of course, all touched by this new regulation that I expect that by the end of the summer will be already in force. And also the changes that needs to be done and will be done probably, if not by the end of this year, next year, they'll be done in regulation 943 from 2019. There are some changes that will be done in 2195 from 2017, and some changes that will be done in regulation 1485 from 2017. Actually, these are the balancing guidelines, the system operation guidelines, and the electricity market design regulations. Also, when they're transported on the national level, it will happen through our national legislation. And I suppose it is coming as we speak, even as we speak. There are some changes that will be introduced, and they will, of course, unlock partially this flexibility that we are talking about. We aim to fully unlock it in quite a safe manner, because if we go to the, let's say, end point at once, we really may mistake something and then just have a blackout, which nobody wants to have, I think. At least I
Certainly
don't
not.
want. I don't know about you.
Martin?
So I already mentioned in my speech where we see already as biggest provider of such services in Bulgaria difficulties, and which can be actually solved very quickly in a couple of weeks, months. So most important is on the shorter term to avoid these difficulties, which also the TSOs are facing, with provision of system services, that the pricing is adequate in order to stimulate the both existing power plants, and I don't talk here only about storage, even conventional power plants. Adequate pricing can keep them in generation in order to provide system services to the TSO, at least for the transition period until the new forms, let's call it, of storages are penetrating more the system. So this, I believe, is quite crucial. Otherwise, we'll see challenges. What we also experience is that the day-ahead market and the intraday markets are actually integrated. So the rules in Bulgaria are the same like in the neighboring countries, while the balancing market is operating under different rules. And this unfortunately creates incentives for participants from neighboring countries to make use of this weakness, this, let's say, improper compared to their, or more favorable compared to their legislation balancing rules to, let's say, to send their imbalances to Bulgaria, because it's cheaper to offload them here. And this, I believe, needs to be very quickly, this inefficiency has
Already
to be solved
solved
very
partially,
quickly.
and we are working toward. Of course, balancing market is one of the main issues at the moment on the short term. because as Martin is saying, what we have at the moment is flexibility, no matter what we are speaking about the future. These are the hydropower plants. And these hydropower plants needs to be preserved. And by means of primary reserve, the reserve that is actually used to maintain the system in all types of disturbances, the first line of defense of this system is actually maintained at the moment by really the conventional power plants. And this is by means of services. What should I say? Security is the most expensive things, actually. Everybody can generate, but providing the security is expensive. So it needs to be properly reflected. I fully agree with this.
Into the market. Ani, do you have an insight? Maybe then Rosa can jump with the best practice example, for example.
Yeah, no, I just want to say that, for example, for storage, we see into the latest electricity market design a lot of opportunity. Now it's not yet low, and it might come maybe at the end of the year, but finally we see a recognition of energy storage, battery storage, and net zero technology. For example, member state will be required to state targets for energy storage, as well as every 2 years to run a flexibility assessment on what they need to cost effectively achieve decarbonization. So that will be a great support for the implementation of storage. And also the net zero industrial plan will bring the manufacturer and the manufacturing closer into Europe, with also batteries and energy storage component that might be manufactured in Europe. So honestly, from our side, from Fluence side and the storage industry, we see positive sign. On the other side, of course, once approved, it has to go to member states to apply them. So the speed of response of member states will be critical to meet then the goal that we have to achieve.
Thank you. Anyone else wants to
Yeah.
comment? Yeah.
I would add that, you know, in practice, we see a lot of barriers when it comes to aggregation of these alternative flexibilities coming from industrial customers, commercial customers, small generation assets. So I think from the point of balancing, the aggregation should be allowed in a way that portfolio-based bidding is possible, because with aggregation of these flexibilities, we can combine all these different characteristics. For example, from the storage, from battery storage, we can get very fast response with a lot of power, but there is a lack of energy, or energy becomes quite expensive. But if we combine battery storage with some industrial assets that are slower, but can actually provide much more flexibility in a long run for an hour or even 2, then this already makes sense, and it's, let's say, an advantage of providing such a service. So this aggregation is important, and portfolio-based bidding to balancing markets is enabling that. So this is something that needs to be pointed out. Another point is the products on the balancing markets need to be suitable for such flexibility, meaning that what we see in the last years, the products are, the duration of the products is shrinking. So with Picasso and Mari, we are talking about 15-minute products. Also on an intraday, we see 15-minute products. And this enables many different flexibility assets to be able to provide these flexibilities. Again, unlocking a lot of flexibility that is currently not able to provide this to the current regulation or to the current balancing product. And the third is that with the DSOs and with the regulation that would allow or that would recognize the flexibility costs that DSO would have, when acquiring these flexibility services for voltage control or congestion management, this would also allow then DSOs to purchase such services from flexibility providers, aggregators, suppliers, or directly, even directly from the customers, and actually help them much more efficiently and actively manage the distribution grid.
So maybe I could build on your point, Peter, here, because indeed, I would like to zoom in from the new electricity market design work that is happening currently in Brussels and is full of promise and opportunities, as was already mentioned, on our local realities and what we actually face currently when different European acts are transposed in national legislation, not always completely reflecting the initial idea of the legislator. So for the distribution system operators, indeed, it seems crucial to be able to know that whatever costs they make in software or hardware related to BESS or flexibility services or software management systems that allow them to take advantage of that software, those costs will be indeed recognized by the regulator, not just as timely, but also future-proof. And maybe if they're upfronted, they indeed have to be taken up through the distribution tariffs. As a regulated business, of course, we are also concerned of the financial stability of these investments over time, and how our ambitions or desires to indeed reinforce the grid today will be accepted by the regulator as something that is an appropriate cost for the society or the economy at this given stage. Also, now we do receive the grants, but how do we ensure reinvestment later on when the assets that we have purchased or the services we have purchased with them today will have to be replaced is another key practical financial issue that is currently for us on the table. And this, to a large extent, from a regulatory perspective in Bulgaria, relates also to our overall ambition and strategy, where we want to go as a country when it comes to the transition, where we would like to see more renewable assets. What's the ambition of electrification of transport? How exactly are we incentivizing customers and households to be active in their electricity demand? Whether we have this blockchain and IoT solutions to allow them to be remunerated real time for the services they might provide to the DSOs are all questions that will determine the degree of investment on the side of the DSOs, and the fine balance of spending just enough really depends on having a clear pathway where we want to go as a member state and a country in this transition journey. So this is something we definitely see is a big challenge locally.
And the last two gentlemen, but really quick was.
Yeah, just one thing, it's everything was said, about the European Union direction, the legislation changes that will be probably forced on us, as well. And one practical aspect, State Energy Regulatory Commission, KEVR, and Ministry of Energy have to start preparing now with the skills, knowledge, and toolbox to be able to regulate the DSOs and the TSOs in the new environment. They currently regulate under the mechanism that is in place. They know they do their job perfectly, and they have to prepare. Everything comes faster. If they wait the legislation first to happen and then to start building the tools and the knowledge, then there will be a gap in regulation. There will be a gap of practical implementation of these changes. So they have to start preparing now.
Thank you for that. That's really important aspect, that you, in order to implement that regulation, you need to have the knowledge of how it works in practice. And Faisal, last word for you.
Yeah, I think as a lot has been saying now, and I'm not expert on this region either. In the DNV, we see a lot of regions and what's going on in the market, and there needs a strong push from the EU and the Green Deal to be able to prolong that. Maybe I draw the attention back because we like to active in the US market and the IRA and what's going on there. That's also a good example on wherever we can push this forward as fast as possible. So that's the last words from me.
Thank you for that. Then we will have up to 2 questions, very quick. If someone wants to ask them from the audience, just raise your hand high so the person with the microphone can see you. Over there.
Hi, everyone. My name is Philip, and my question is, how much from the balancing energy is currently imported from abroad?
That goes to the TCO.
None. I promise to be brief, none.
None.
Fortunately for us, okay, I'll give some insights. Fortunately for us, we have enough flexibility sources thanks to the hydropower plants that we can use, and thanks to the thermal power plants that we are using at the moment. The reasons and the consequences from financial point of view were explained earlier today by Martin. But at the moment, only a very small part is coming, mostly going through IGCC platform. We are not still connected to Mari and Picasso. It is expected to happen next year. But of course, in order to design again needs to be done. And this is foreseen to be done by the year, because introduction of standard products, of special products, redesigning the way the pricing is done, and so on and so on. This everything on the balancing market. But at the moment, in general, we are exporter of flexibility services, then importer. And also we still manage to maintain all of the reserves that are needed for our control block through national generation. This goes for all the reserves according to already mentioned system operations guidelines. I think this answers. Maybe you need more?
Thoroughly,
No?
I think. So last question, if anyone wants to. If not, we will be moving into the next panel. Oh, one question there.
Hi, thank you. My name is Luca. I'm from ICIS. I want to ask you, how quickly can HDVC cables can be introduced in Southeast Europe, and how much will that cost? Thank you. Oh, smart grid.
Who would like to take that question?
HVDC. Fast enough. Really, very interesting question. HVDC is technology that is just shifting the power, the active power. Actually, they're useful. If they're foreseen for some interconnections, it will be good. They have advantages, of course, disadvantages. I don't think that there is a regulatory gap or bottleneck or something like this. HVDC is to be built, but at the moment in the region, we are counting mainly on asynchronous transmission, of course, because this helps us to exchange stability, let's put it this way. HVDCs, if you are talking about the region, the projects in Greece. At the moment, they have a project for connection of Crete. They have one project that is already on to connect from Crete to Israel, and there is a project to connect Israel to it was somewhere in North Africa, I don't remember. Also, there is a project already announced between Romania and I think Azerbaijan or Kazakhstan, I don't remember actually, but also it's for submarine HVDC. It is intended this to be built with participation of several countries, and it will connect these 2 points, these 2 endpoints, going through really the whole area of Black Sea. So there is no problem with the introduction of HVDCs, only it's a matter of finances and returns. of the investment.
As with all projects that we currently have, first come permitting, then the business model, and implementation takes really fast after that.
Yeah.
So with that words, I will close our panel. Thank you to all the panelists. I think that we covered more than we bargained for at the beginning. And I hope that the audience is happy with our panels too. If not, you can chase us outside the hall, because now we are making room for the next panel who will present you the next half. And my panelists, please join me to exchange the, the microphones.